Hey there and welcome. Today, we're going to put on our detective hats to solve a little mystery that's hiding inside an algebraic equation. Okay, I know what you're thinking. At first glance, this thing looks like an absolute nightmare. Your first instinct might be to just start multiplying everything out, which, trust me, would create a huge, messy polynomial. But here's the secret. There's a way smarter way to solve this. And that's a fair question, right? When you see an equation like this that says it's true for all x, that is a massive clue. See, what that really means is the thing on the left, it's just a cleverly disguised version of the thing on the right. Our job is to figure out that disguise. So instead of just, smashing through it with brute force, we're going to be strategic. We're going to be detectives. We'll look for specific clues that'll help us find the values of our unknown constants, a and b, one at a time. This method is faster, it's cleaner, and honestly, it's way more fun. First up, our target is the constant a. We're going to start by hunting for the single biggest clue in this whole equation, and it's hiding in plain sight. Just think about it for a second. To get an x-cubed term, you have to multiply something from the first set of parentheses with something from the second. So what are the only two terms on the left that, when you multiply them together, give you something with an x to the third power? That's right. The only way to get x cubed is by multiplying that ax from the first part with the 5x squared from the second. Everything else? It's just noise, at least for now. We can totally ignore all the other combinations. And look what that gives us. We have this beautifully simple little equation to work with. We know that this multiplication on the left has to equal the x cubed term on the right. They have to match. And if 5a times x cubed is equal to 20 times x cubed, well, then the numbers in front, the coefficients, they've got to be equal to each other. So the big takeaway here is 5a must equal 20. And just like that, with one super simple division, we've cracked our first code. We know for a fact that a has to be 4. No other value could possibly work. That's our first big break in the case. All right, awesome. Now that we've got a figured out, we can use that information to help us find our second unknown, which is b. And guess what? We're going to use the exact same strategy. This time, we're on the hunt for the x squared term. So let's look at the left side of that equation again. How can we combine terms to end up with an x squared? Looks like there are two ways to do it this time. Okay, let's break this down. First up, we can multiply ax by negative bx. And then we can also multiply 3 by 5x squared. When we combine those two, we get the total x squared part on the left. And since the whole equation has to be balanced, we know the combined part has to equal the x squared term on the right, which is negative 9x squared. And just like before, we can totally just ditch the x squared part for a second and look only at the numbers in front. This gives us another simple equation to solve. Negative a plus 15 has to equal negative 9. And hey, this is where our earlier detective work really pays off. We already solved for a. We know a equals 4. So we can just plug that right into our new equation. Okay, now it's just some simple algebra. We just subtract 15 from both sides, and that gives us negative 4b equals negative 24. We are so close now, I can feel it. And finally, we just divide both sides by negative 4, and we get our answer for b. Boom! The second unknown is 6. This case is practically solved. Okay, so we've got our a, and we've got our b. Now all that's left is to actually answer the original question. Let's put this all together. Now hold on, before we celebrate, let's always go back and check what the question actually wants from us. It doesn't just want a or b by themselves, it wants the product of the two, a times b. So we just plug in the values we found. That's simply 4 times 6. And there it is. The final answer is 24. No mess, no crazy expansion, just some clever detective work. And if we look back at the original problem, our answer of 24 matches up perfectly with option C. Case closed. So what's the big takeaway here? I mean, this wasn't just about solving one little problem. It was about learning a really powerful technique that you can use over and over again. So here it is, your new detective toolkit. First and most importantly, don't panic and just start multiplying everything. Look for a shortcut. The key is to match the coefficients.
Start with the highest power terms or even the lowest ones, because they usually have the fewest moving parts and give you the easiest equations to solve. When you do this, you turn one giant, intimidating problem into a couple of small, simple ones.
You know, this whole idea of matching coefficients, it's an incredibly powerful tool. So the next time you see a problem that just looks impossibly complicated, take a breath and ask yourself, where are the clues? You might just be surprised at the simple puzzle hiding inside. Thanks for cracking the case with me.